Okay, now we're going to turn our attention to the F&E calculations on the two coarse aggregates of this blend. We will look at our number 8 stone first. So take a moment, look at this worksheet. We're going to be concentrating our efforts on 3 different columns: column B, column E, and column F. In the middle of the page, the calculations, the formulas are provided in the middle of the page to arrive at the values. So column B is simply the sum of the percent retained on the 4 and above. So if you look at column A, the 10.2 that's retained on the 3/8 and the 63.4 that's retained on the number 4, you add those two, that would be the sum of percent retained on the 4 sieve and above. So we're going to take each sieve separately. So let's look at our 3/8 sieve. Column A, which is 10.2, you want to divide that into the sum of the percent retained on the 4 divided by 100. 10.2 divided by 0.736 yields us a 13.9 on the 3/8. On the number 4 sieve, column A, which is 63.4, divide that into the value of the sum of the percent retained on the 4 divided by 100, which is a 0.736. Also, 63.4 divided by 0.736 yields us an 86.1. Just as a reminder, when you add the 13.9 and the 86.1, it should be 100. Kind of use that as a self-check moving forward. If it's not, sometimes it's 99.9, sometimes it's 100.1 or 100.2. If you're not close, if you're off further than that, there's probably been a mistake made in that calculation. So then now let's look at our column E. In the middle of the page on number 4, you will see the formula for column E. It's column D divided by column C times 100. Column D representing the weight of failed particles, column C representing the total weight of particles collected. So for our 3/8 sieve, it's going to be 1.6 divided by 116.9 times 100, which yields us a 1.4. For our number 4 sieve, column D, 1.7 divided by 60.9 times 100 yields us a 2.8. Let's move to column F. And in the middle of the page under numeral 5, column F, the formula is column B divided by 100 times your column E. Column B represented the plus 4% retained divided by 100 times column E. So let's look at our 3/8 sieve for column F. It's going to be 13.9 divided by 100 times 1.4. It's going to yield us a 0.2. For our 4 sieve, 86.1 divided by 100 times 2.8 yields us a 2.4. Add those two values, 0.2 and 2.4, our answer would be 2.6 on 5-to-1 ratio. Let's look at our second coarse aggregate that involves the F&E calculations. So we'll look at the number 78. Again, we're going to calculate column B, E, and F. The second portion of the formula for column B, the sum of percent retained on the number 4. So if you look at your column A, for your half, 3/8, and 4, the 2.6, the 33.2, and the 51.1, you add those 3 values, will yield you a 86.9. So So on column B, let's look at our first sieve, which is a 1/2 inch. We want to get to 2.6, divide that by 86.9, divided over 100 is going to yield us a 0.869. The 2.6 divided by 0.869 is going to give us a 30. We'll look at the 3/8 sieve, 33.2, divide that into the answer of 86.9 over 100 will give 33.2 divided by 0.869, which yields you a 38.2. We'll look at the 4 sieve, the 51.1 divided by 86.9 over 100, which is 51.1 divided by 0.869, yields you a 58.8. Column E is column D divided over column C times 100. Column D representing the weight of failed particles, column C representing the total weight of particles. We will now calculate column E portion of this calculation. Column E, the formula is column D over C times 100. Column D representing the weight of particles that failed. Column C representing the total weight times 100. I just want to remind everyone that on the 1/2 inch sieve, we had less than 10% retained on that sieve, meaning we did not physically test any material on the 1/2 inch sieve. I say that because we still need to recognize this in our equation. So if you look at column E, you have 5.2 written down twice. We got 5.2, which we will use that value in calculating the 1/2 inch material that we physically didn't test because it was less than 10% retained. So let's go ahead and look at the 3/8 sieve on column E, which is 4.0, which is the weight of the aggregate that failed. Divide that by 76.4, which is a total aggregate weight, times 100 yields us a 5.2. Again, we will simply move that 5.2 up to the 1/2 inch. So we'll look at our number 4, 6.8 grams that failed, divided by our total weight of 117.6 times 100 yields you a 5.8. Now we will look at column F, which is column B divided by 100 times column E. So we will look at our 1/2 inch sieve. It's 3.0 divided by 100 times 0.30, which yields us a 0.2. So let's move on to the 3/8 sieve. 38.2 divided by 100 times 5.2, that yields us a 2.0. The number 4 sieve, 58.8 divided by 100 times 5.8 yields us a 3.4. You add those three values, 0.2, 2.0, 3.4, for the three corresponding sieves, gives us an answer of 5.6% on the 5-to-1 ratio. Let's now turn our attention to the wrap properties. when we looked at our 2 fine and 2 coarse aggregates and we were determining our GSB values, now we're looking at our wrap. On our wrap, we are going to use the GSE for our GSB. So we ran our GSB on our 8s, our 78s, our B sand, and our natural sand. Wrap is covered in asphalt, so we got to use the GSEs when we do our final calculation for the mix design. So there's a couple things we need to look at in this calculation, some things that we need to determine first. So if we look at that calculation at the bottom of the page there on the left, you see 100 minus PB, PB meaning percent binder. So we need to determine our binder content of our wrap. Then you're looking at binder gravity, which is pretty certain, safe to say that most use a 1.030 for your binder gravity. That's the value we're going to use in this example. And now you're looking at your GMM, your maximum mixed gravity of your wrap product. So let's look at the top of the page in that first table where we have sample 1 through 4. What we did when we collected our wrap, in using our muffle furnace oven, we did 4 burns using a correction factor of 0.40 to determine our binder content. So on test 1, sample 2, sample 3, and sample 4, we have our individual binder contents. We're going to add those 4, divide by 4, and it gives us a binder content of the wrap of 5.00. Now the table in the middle of the page is our GMM. We actually ran a rice test, 2 of them, on our wrap. So our first test, we have a 2.589 GMM. On our second test, we got a 2.585 for that test. So let's add those 2, we'll divide by 2, and our average is a 2.587. So knowing our asphalt content of a 5.00 and knowing our GMM of a 2.587, we can move forward in calculating our GSE. So the first portion of this equation is 100 minus PB. So it's 100 minus in your asphalt content, your percent binder, which will give us a 95. The second part of the equation is 100 over GMM. You do that calculation, yields us a 38.655. We want to subtract that by our percent binder divided by our binder gravity, which is 5.00 divided by 1.030, which yields us a 4.854. 4.854 from a 38.655 gives you a 33.801. You do that calculation, 95 divided by 33.801, and our GSE value that we will use in this mix design is a 2.811.